projectile, and we're going to create a enemy. So we're going to create a 3D object, make a cube. We're going to name this enemy. We're going to tag this as enemy, and I need to take a step back because I need to go back to the projectile for a second before I get to enemy. So the projectile, if we look at it, they live forever. We don't want them. So we're going to create a script. And this script, we're just going to name it projectile script. Yeah, that's not going to be there. We're not going to have anything else in there. And in the projectile script, what we're going to do is very simple. We don't need start. We just need this to happen in update. Now, this, if I go up here, and this is, if you got this set up properly, camera, you need to bring it to so that it's -30 along the z-axis or the x-axis, and you should have a fairly large game area. Now, the reason why the game area is so large is for the simple fact that once we get our final assets in here, they're going to be slightly bigger, and we want to have enough play area to make it interesting. And the play area and how far the camera is back, everybody has to follow that. If you're not on the same axis as I am, then the only other axis you could possibly use is Z. So that means X will be -30 back. But regardless, 1280 by 720, that gives us a fairly large game area. We're not going to have huge ships in here, but we want a nice deal of game space, and it's going to get smaller as we get some of the final assets in. All right. So here, for me, this is, I think I kind of figured this to be about, so it looks like -29 and 29 for me. I think I may have went to the very edge and said 30. But let's work with 29. And really all we need is forward 29 because back doesn't matter. And this is what we're going to do. So if transform dot position dot x is greater than or equal to 29, we're going to destroy this game object. In our prefabs projectile, we're going to attach this script. So component, scripts, projectile script. And it works. All right, let's go back to the enemy. We already created our tag enemy. We're going to tag it. And now let's create a script. And we're going to attach this to our enemy. So we're going to do a couple of things here. First off, let's create some ray casting. Raycast hit. Float. Ran. Pos. Y. Float. Start position. Next. All right, so start. You know what? Let's not. Yeah, let's. I'm going to go ahead and start out with a function. So, and we do. Make this a public void start or reset enemy. And I guess we can do this. Oh no. Let's say speed min will be a minimum of 1. Speed max, let's say a maximum of 5. And we'll put speed increase, but we'll leave that blank for right now. So what we're going to do is this. So start off with speed is equal to a random dot range speed min speed max. And then we're going to throw this in here. We have that. Let's not forget the semicolon. And then what we're going to do is float amount to move is equal to speed times time, delta time, and then transform, translate, and we're going to translate vector 3 left. Now the other thing we need to do is set its initial position. So we know here, when we create this, I don't want this all the way up here, don't want it all the way down here, but probably a good, area with providing a little bit of a safe zone might be, looks like 14. Let's do 14 and let's do positive 14 and negative 13. So our ran position y is equal to a random range. Our min is negative 13, and this is for our height. Our max is 14. And transform dot position since we're here, let's go ahead and get our start position. Start position is equal to transform dot position is equal to a new vector 3, and our start position dot x. We're going to use ran position y and start position dot z. Cool. And we're going to build it. Now, when we have our enemies are going to start off screen. And eventually, we're going to spawn our enemies on screen, but we're not doing that right now. So we hit this, and it works. Now, it just goes off screen, keeps going. So what we're going to do is get our enemy, and let's say when it's here, off screen, and we'll do -34. So if transform dot position dot x is less than or equal to -34, then what we're going to do is use our function again. And that's a little fast, so I'm going to bring this down. We'll go to 0.5 and let's say 2 for right now. And the other thing I want to throw in here into speed is the speed increase. Right now this is 0. So plus this, and then we multiply it. And we're using some of our, please excuse our dear Aunt Sally. That, and still a little fast. Faster than I expected. That's okay. Oh, duh. And that's because I don't have this multiply by my amount to move. I was just moving along that per frame. There we go. So yeah. And then we can choose to, so let's say, there we go. There we are. And so that we have that working. Now, the last thing I'm going to place in here before we go on the break is we're going to start skeleting in the conditions that will happen if the enemy sees the player, or give the ability to the enemy to see the player. So public void see friend or foe. And what we're going to do is just debug it for right now. So debug draw array. Let's create vector 3 transform direction, and that's transform right, but I'm going to make this negative, and then we're going to multiply this times 100. So the bug draw array will use transform that position forward and color, let's use red. And we'll fill this in here. Right now. All right, so you see that that is a debug which allows us to see the direction that our array is going to possibly go. And we haven't really done too much with rays outside. Well, we've done a little bit with the base defender game. But we're going to do something a little bit different, and as in have the ray, instead of it being created where we place our cursor, is based upon our object. I don't need this at 100, so I'm probably going to bring this down to 25. Now, what we're going to do is use a physics raycast. Where we're going to cast it from is our transform, not position, forward. We're going to get our out hit. Actually, I don't need the actual, I don't really need this, but let's count it out for right now. We need transform position, forward, out hit, and then we need the distance, and I'm going to make that 25. And what I'm going to do is, we need to create an actual if statement. If. And what I'm going to do is, if it hits the player, we're going to say I hit the player. So just if hit dot collider dot game object dot tag is equal to player, the bug log I hit the player. Test it again. So every time we hit the player, it recognizes it hits the player. And what we're going to eventually do is tell it when it hits the player to fire a projectile, or to maybe process a random variable to see if it can fire the projectile, and then also have it fire at a particular rate. But we're not going to do the enemy, we're not going to set up the enemy firing the projectile today. What we're going to do next is set up the player being able to hit the enemy and send it back. And then after that, once we add some more, we'll get into actually having the enemy fire at the player. Okay? Take a break and be back in